and we will also cover how you can use that to enhance your security. My name is Bharath. I am a delivery consultant at AWS. My co-speaker for the session will be Chethan.
Hello everyone, myself Chethan. I am also a delivery consultant at.
Let's go to the agendas for today's session. We will be talking about what a login event trigger is. We will be also talking about the key consideration that you need to keep in mind while designing your login trigger function code, and also how to recover from a broken login trigger. And Chethan will cover the use cases focusing on security and also the best practices, and then we will open it up for Q&A. Postgres had event triggers for a while. The difference between a normal DDL trigger and an event trigger is that a DDL trigger fires on a DML operation on a table, whereas an event trigger fires when a specific event occurs in a database. Currently, 4 types of events are supported, which are DDL command start, DDL command end, SQL drop, and table rewrite. For example, DDL command start captures the event after a DDL operation such as create, alter, drop, revoke. And similarly, DDL command end captures the event after a DDL statement. SQL drop fires when you drop a specific object from a database. It could be a table, function, or a view. And similarly, table rewrite event occurs when you add a new column to a table or alter an existing column in a table. Now in PostgreSQL 17, we have a new event which is called login. I'm sure a lot of developers have been waiting for this feature, and it's finally committed in PostgreSQL 17 because it basically bridges the gap between other commercial RDBMS engines. So what is login event? So basically it fires when the user connects. It gives an ability to fire a custom code whenever the user logs into the database. And why is this important? Previously, if you need to implement this functionality, you may need to write a lot of custom code or use extensions or use connection login hooks or constantly poll pgstat activity and trigger an action based on it. But now that the feature is natively available in Postgres, it provides a tight integration. And also it opens up a lot of use cases that you can use. For example, the prominent use cases that you could think of is you could use it to initialize session data or create personalized environment for the user. You could also create a dynamic role based on the day and time of the login of the user. The use cases are many. This is a powerful feature and also a very dangerous feature. Why? Because any error you make in the trigger function code will lock you out of the database, and even the super user cannot log in. So you need to be extremely cautious while using this feature. So let's look at some of the key differences between a normal trigger and an event trigger in terms of scope, timing, and event type. In terms of scope, the scope of a normal DDL trigger is that of a table, whereas the scope for login event trigger it's at a database level and fires on a connection when the user logs in. In terms of coming to timing, login triggers fires at the beginning of the user session before any SQL commands are executed, whereas other DDL event triggers fire after a specific SQL operation. Login events login event respond to a connection event, whereas other event triggers respond to DDL events. Let's look where it fits exactly in the connection process. Login triggers fires after the successful authentication, before sending any response back to the client, and it occurs before session initialization. So this makes it a great place if you wanted to configure some session configuration related to the user. It could be like workmem or session timeout, right? Let's look at this diagram so that things could be understood much better. So in a normal workflow, the user connects to the database, submits the credential, and gets authenticated. In case of login event trigger, after the successful authentication, the logon code which is associated to the login event gets fired. If there is a successful execution, we get a successful response and the user will be able to log in. In case of failure in the trigger function code, obviously the trigger function is going to fail and the user will not be able to log in. In order to reduce connection time overhead when there are no login triggers in the database, a new column has been introduced in PG underscore database. It's called dat as login event. It's a Boolean value. This value is set to true whenever you create a login event trigger, and set to false when you drop the trigger. Like other triggers, you could have multiple logon triggers in the database. In case of multiple logon triggers, the trigger will fire based in the alphabetical order. And also one thing you need to keep in mind is that, and whenever you cancel in progress login connection, it won't cancel the in progress login trigger. Let's look at the syntax of event trigger. The syntax remains the same for all the event trigger, but one thing which I wanted to highlight here is that for the normal DDL event trigger, you could apply a when clause. For example, using this when clause, you could design a DDL event trigger which could fire only for specific DDL operation like create or drop. At the moment, you cannot use a when clause for login event trigger. Maybe in future versions, we could see this get implemented. So I have given an example below. The two components for an event trigger are the event trigger function, right? The event trigger function always returns the event underscore trigger, and it does not accept any input parameter. And after creating the trigger function, you tie this to an event. In our case, it's a login event. Let's look at some of the key considerations that you need to keep in mind while designing your trigger functions. So in this example, whenever the user Bob tries to access the database Postgres, we restrict the access. In all other scenarios, we capture the entry into a log audit table. So the first consideration that you need to keep in mind is that whenever you are using DML operation or trigger function code, make sure that you check that the database is not in a recovery state. Logon triggers will fire even for replica on standby. So obviously when you perform something DML operation, it's going to fail. And the other thing is that since logon trigger will be fired for all the users logging into the database, either you give the permission to all the users or define the function as security definer so that the function runs with the permissions of the function owner. And always keep your trigger function lightweight so that there are no delays, and don't add too much business logic in the trigger. Keep it simple. As I mentioned before, whenever there is a failure in the trigger function, it could lock you out of the database. So are there any paths for recovery? Yes, there are two ways for recovery. Let's look at the first method. First method is starting the database in a single user mode. The steps involved are you need to stop the database and then restart the database in a single user mode. Either you drop the trigger or fix the trigger which is causing the issue, and then you restart the database in a normal way. By following the steps, you could be able to recover from the logged out situation. Some of the pros are it allows direct access to the trigger and it doesn't affect other database settings. Cons with this approach are you are starting the database multiple times, so obviously there is a downtime and it may impact your other ETL jobs or other process which is running in the background. Let's look at the second method. In PostgreSQL 17, a new configuration parameter has been introduced which is called as event underscore trigger. This controls the enablement and disablement of event triggers. So and obviously this parameter does not require a restart. So by any chance, if you are connected to the database and you wanted to disable the event triggers, you could very well run a command alter system, set event triggers to off, and then reload your configuration. This works when you have a session already connected. But in other cases where you are completely logged out of the database, you could not use this method using the event trigger configuration flag. So the second variant is using the
So I have a question on that. If you have one cluster with 50 databases, it sounds like this is a database level parameter, correct?
Yes.
So you could connect to another database that's on the cluster and still execute something like that, or no?
No, it will, even though we create the logon trigger at the database level, if there is any failure in the function, it will lock you out of the database because the logon trigger fires after the authentication but before establishing a session. So any user will not be able to log in.
So even though there's a setting to say whether it's on or off for each database, it's actually a cluster level?
Yes, correct.
Okay. Okay, got it.
So we will look at using the event configuration when you are completely logged out of the database. So in this method, obviously you need to log into the machine, edit the PostgreSQL.conf file, set event triggers to off, and then you drop the trigger or fix the trigger. So by doing this, now make sure that you don't encounter the same issue again. So after fixing the trigger code, again you reset the event configuration to on and then reload the configuration. By following these steps, you would be able to recover from a failed logged out situation. Some of the pros with this approach are it's simple and quick to implement. It doesn't require a database restart. Some of the pros. The cons with this approach are it disable all the event trigger. Not only your login trigger, it will disable all the DDL event triggers as well. And obviously you need to have access to the machine super user, and then obviously you should have permission to the config file to make these changes. These two methods work when you are running Postgres on a simple EC2 or a virtual machine. When you are running Postgres from a cloud provider or a vendor, these methods won't work. Why? Because obviously you will not be able to access this file, or you will not have access to the underlying host. In these scenarios, either you need to contact the vendor or cloud provider to fix this issue. So be extremely cautious while using this feature, and make sure that you pick up the right use case while implementing this feature. Now I will hand it over to Chethan, who will cover the use cases focusing on security and also the best practices while designing the trigger function code.
I have one question. Does this feature can be say applied to Aurora, Postgres and serverless models, or like?
No. This feature, whatever the workaround we are told, right, we cannot use it for any cloud provider.
Because PostgreSQL.conf is not visible.
Yes, correct. Yeah, because we don't have access to the Postgre.SQL file. So obviously you need to contact the support team to come out of the situation.
Okay, but this logon feature can be leveraged in this serverless and managed.
Yes, correct. PostgreSQL 17 from PostgreSQL 17.
Configuration parameters.
Yes, correct.
And in case of any issue or any problem, then
You need to contact the support team. You cannot come out. Obviously, you need to contact the support team to come out of this.
I'll be talking about the use cases of login event triggers. The first use case is security and audit logging. In this use case, we are going to have an audit trail for database access. I have a simple audit table here, which has the user, database you are trying to log into, and the client IP address and the login timestamp. You can have additional attributes along with this table, like other user attributes, be it application name which you want to log in, which you are going to provide while logging to the database, whether you are using SSL to log in to the database, and you can also have an additional attribute to say whether the login was successful or failure. Basically, the login event trigger is going to raise an exception to reject the connection. So that's when you can say the login is failure and populate the data accordingly. And here a simple trigger function. In this trigger function, I'm inserting data into the login audit table. We just select the current user, the current the database, and the IP address of the client from where the login request is coming. So we are going to insert that data into the login audit table. And prior to login event triggers, we had other options, log connections and log disconnection attributes, which are configuration attributes, which are there in PGConf, where you can change this, enable these configuration items and have the logging and logging for connection and disconnection. And we can also query pgstat activity to see what are the recent login events. Using this login audit table, we can basically see we can achieve, we can do security audits, compliance requirements, and troubleshoot the login related issues. And some of the key consideration for the login audit table are we should define the data retention policy on this table. We need to come up with the store procedure which is going to purge the data in the table, and we need to delete the data accordingly. For example, if you want to retain only 6 months of data, you can have a store proc which is running on daily basis and truncate the table, purge the table. And considering the table has some sensitive information like IP address and the client user information, we might have to provide the right permissions on the table. And there can be some security incidents which can be happening on the database, like there will be a user or a client IP address which is trying to connect to the database with multiple failed attempts, and you have a suspicious IP address which is trying to logging into the database. So such security incidents can be, we need to have an alerting mechanism for such security incidents. And if the table grows to be very big and you can think about and you want to hold on to the data, then you can think about partitioning the login audit table as well. Second use case is session and access control. In this use case, we are trying to restrict the user to log into the database based on certain checks. As you can see in the first use case, first trigger function here, we are restricting the user based on time. So we don't want the user to log in off business hour. I mean, basically we are checking the day of the week from the current timestamp, whether it's between Monday to Friday, and the hours between 9 a.m. to 5 p.m. And if it is not this case, then we are restricting the login to the database. So the logic in this particular function can be made a bit more complex. We can let the super users like Postgres, admin, and other super users log into the database throughout the day, whereas specific users can have this rule. And we can also restrict the login to the database based on the application name. If the application name is not specified while connecting to the database, we can restrict the login to the database. And limiting connection is another use case where you can restrict a specific user based on number of concurrent sessions he is having. For example, if you have a requirement like a user can have 5 maximum concurrent sessions running, then we can limit the user based on querying the PGStat activity and see if the user or the IP address has a count of 5 active sessions. If it's more than 5 active sessions, we are going to restrict the user from connecting to the database. Block the login from the suspicious client. Basically, we can we get the IP address of the client and we can check for the IP address pattern, and we can also use Postgres IP address data type and do certain checks and identify if it's a suspicious client. We can block the suspicious client based on that check. We can enforce SSL. SSL is something which is going to help us to help client to communicate with the database with encryption and secure the connection between the client and the database. To enforce SSL, what we can do is we can, in the login event trigger function, we are going to check whether the SSL is used to connect to the database or not. If not, we are going to reject the connection by raising an exception and stating you need to use SSL to log into the database. So we have looked at certain checks which we can do to restrict the users. So these can be used in combination or individually. And before raising an exception, if we make an insert into a separate table called failed login attempts table, which has the information related to why the login was rejected and which was the IP address and which was the username who was trying to logging in and why it was rejected. So if we have that information, what we can do is we can query this particular table to see if there was a failed login attempt in last 5 minutes. If there was a failed login attempt in last 5 minutes, we are going to reject the connection by raising an exception and stating there is a failed login attempt in last 5 minutes. You might have to retry again. So dynamic resource management is not exactly a security use case, but we can use it for initializing the session. In this small store proc, in this small trigger function, what we are doing is we are setting certain session level configuration parameters. In this trigger, we are setting the work mem based on the user. If the user is Postgres or admin, we are setting a certain work mem. And if it's a certain time in the day, we are setting a certain work mem. And if it's a default case, we are setting a certain work mem. At the end, we are basically creating a dynamic SQL and setting the work mem. And we can do it for other configuration variables as well. If the query is complex and you have a lot of aggregation, we can set a maintenance work mem. And we can use maximum parallel worker per gather, set it as well, temp buffers, and search path is another configuration variable which can be set at the session level. And the statement timeout and the lock timeout is also something which we can set at the session level. There could be other session configuration variables which you will be able to set and initialize the session for running queries. And in this trigger function use case which I showed, the user-based configuration session variables are being set, and based on time it is being set, and you can do it based on the application name. For a specific application, we could be able to set certain session variables before starting running queries. And based on the role of the user also, we will be able to set the configuration parameters. A row level security is a way we can restrict the user from accessing certain set of rows in the table. This way, this is for security and compliance requirement. This is one of the important features in PostgreSQL. Here, what we are doing here is we are setting the table in the trigger function. We are setting the table for row level security, enabling the table for row level security, and we are creating a policy to restrict a user from accessing the rows created by him. So the logic could be much more complex in the sense, if it's a super user or the owner of the table, if he is a Postgres or an admin user, he should be able to access the whole table, but only specific users should be able to access only the rows created by them. This way we are going to restrict the user from accessing rows created by others. So this row level security also can be set at by checking different things. For example, for a specific user, you can set the row level security, and for a specific role or a specific application, we can set the row level security based on the need. Dynamic role management is a use case which you find in Postgres documentation as well for login event triggers. In this use case, we dynamically assign the role to the user at the time of login. In this use case, as you can see, based on the time of the day, we are assigning a role, granting a role to a user dynamically. So we have two kinds of roles here, the day worker role and the night worker role. Based on the time of the day, we revoke the, for example, if you are logging in during the day, you revoke the night worker role and grant the day worker role. And during the night, you revoke the day worker role and grant the night worker role. The logic would become much complex in the sense we can check what is the existing role, and based on that, we can check whether we have to revoke or retain the existing role as well. So this is based on certain time during the day, and we can also grant the role dynamically based on other user attributes as well, user metadata, and any other connection properties. For example, if a specific application is trying to connect to the database, we can revoke a certain role and grant a certain role dynamically. I have additional callouts. I have covered 5 use cases. There are additional callouts. In this callouts, recording connection patterns. In the first use case, we talked about having logging data into the log audit table, and log audit table and failed login attempts table. So these 2 tables will have the connection patterns. We can run some queries against these tables to see if what time of the day the most number of connections comes in, and which user has the most failed login attempts. So such kind of questions can be answered by writing some analytical queries against these 2 tables. And tracking resource usage is also something which you can do as a part of login event trigger. As and when you log in, you can also log the information related to what configuration variables, session level variables parameters are we setting. Those values can be basically logged in the logging table as well. Basically, this session uses maximum parallel worker per gather a certain value or a work mem of certain value, so that also can be tracked. And there can be some security incidents which we can identify. Basically, if there are a failed login attempts from a specific IP address, multiple failed login attempts from a specific IP address, then such kind of security incidents can be alerted to the right team. And initializing temporary table is also a use case where you can initialize a small temporary table, not a big one, considering it would add latency to the login event trigger, and use this temporary table throughout the session. And we can use this temporary table to cache some data. Here are some of the best practices for login event triggers. Here we would like to keep login event triggers as lightweight as possible. I mean, we know we can have a lot of checks, a lot of business logic in the code. We can we would like to keep it as lightweight as possible, as it adds connection delays. And as Bharath discussed, having a failing login triggers would restrict users from logging to the database and would result into some downtime. We need to test the triggers thoroughly. Basically create a function, test it out, and see if it works fine, and then go ahead and create a trigger function and the trigger later. And handle exceptions appropriately, because having an error in the table would result into not logging into the database. And document the trigger as it affects the system-wide behavior. And if you have a very high traffic database, you need to consider the performance implications, as login event trigger is going to add additional latency to the login process, and it adds to the performance of the query as well. These are certain references. There is a Postgres 17 documentation which talks about login event trigger, and dynamic role assignment is one of the use case which has been called out in the documentation as well. You guys can take a look at that particular documentation. And I'll hand over to Bharath to summarize the session.
Just to quickly summarize, login triggers provides a powerful way for you to control and manage database connections. Using this, you could enforce security policies and also enhance your security posture. So we also say like what is the configuration parameter that you can use to enable and disable the configuration triggers, the login event triggers, and also be extremely cautious when using this, as you might get logged out of yourself from the database. And in case of cloud provided Postgres, you need to contact the support team. So we are ready to take Q&A.
Just a quick question. How can we segregate that a normal user gets logged out and a super user remains logged in?
No, at the moment we cannot segregate it. Like even if a user gets logged out, it affects all the user and no one could log in, even the super user.
Okay. Logging of one user cascades to all the
Yes,
other
correct.
users.
Yes.
This is a limitation, right?
Yeah, it's a powerful and dangerous feature.
But there are chances like 10 users are there, one could cause a problem to remaining 9 also.
Yeah, but that's how the functionality is there right now.
No, sorry, I think the question what he's asking, once there are 10 user session already been established,
Okay.
11th user is coming in, that connection is been terminated due to certain checks. Are the 10 connection having session being terminated is what you saying?
Okay, you mean to say that there are already existing 9 connections and the...
Let's take a random scenario of, let's say 50 to 100 sessions that normally exist on the database, right? So let's suppose a problem is caused by one particular session. So how will it impact the other sessions that are already connected to the database, and how to avoid the impact? Because to leverage this functionality, I think we have to check out the limitation side also. This can cause a problem on a cascading effect, then I think this.
Yeah, I may need to check on this, like whether it might impact the existing connections or only it will impact the new users who are making a connection.
What side of it is existing?
Yeah, correct.
Existing sessions or a newly?
Definitely for sure a new session cannot be made, but whether it will impact the existing sessions which are already connected, I can check and get back to you.
I don't think so it will impact existing
Yes.
because they've already logged in.
They are logged in. Only for the new users, it might obviously they cannot log in. Yes, it always happens after the successful authentication and before establishing a session.
So you said there are failure attempts also been captured. So if it is a successful authentication, then failure, how it would be captured?
You want to talk about that use case?
Failure attempts will be captured when login event trigger is basically rejecting the session, basically by raising the exception. Before raising the exception, I'm logging the failure login attempts.
Okay, that's
So
the
that
logic basically. It's not
yeah.
about this event.
Yeah.
Triggers, but once the trigger is
Yeah,
executed-
before raising the exception, it ensures we log it into login audit table, and this is the reason why I'm rejecting the login.
No failures been
No,
captured.
no.
So if authentication failed, if you didn't have a password, if your password was wrong, you didn't get authenticated, you would never find it.
That's correct.
Because you never made it to authentication.
That's right. Yeah.
Okay.
One question here. So if I'm migrating, say, from Oracle to PostgreSQL, now Oracle also has these login triggers. So how different would that be? And does it cover all the functionality that Oracle provides, or do I have to do extra stuff here?
The core functionality remains the same, right? But one difference I could see is that in Oracle you could have a logon before and after event, but in Postgres we have only login event. And in Oracle we have a logo trigger, but in PostgreSQL we don't have at the moment. And one more distinction could be like in Oracle you could not control, if there are multiple logon triggers, you could not control the order by which they fire. Whereas in PostgreSQL it's always based on the alphabetical order it will fire.
On that same thing, like you said, like we can define the multiple logon triggers on this particular database, and it will fire on the basis of alphabetical order. Suppose any failure happen in any particular trigger, we'll be able to drill down to that particular trigger, or we can say that.
You mean to say that there are multiple logon triggers and there is a failure?
Yeah, and then no one able to log in into the server, and we wanted to fix that.
Okay. So basically you wanted to identify which trigger caused this issue. So obviously when there is a trigger failure, it gets the message whatever you write in the trigger function code, right? When the user tries to connect in, the messages just get printed in the session. So at that time it will give like fatal login trigger function. Due to this trigger function, the user is not able to log in. So with that you will be able to identify.
One clarification. Is there a one login trigger per database, or there may be multiple login triggers per database?
Yeah, you could create multiple login triggers per database.
Oh, you can.
You can create. In this case it will fire in alphabetical order.
The different policies, right?
Yeah, different policies, obviously, right?
Logic is
Multiple
that
login triggers also,
is
the impact cascades to all the.
Yes, correct, yes, correct.
Big limitation.
Yeah, Jim, yeah.
For your example and use case 4, does that effectively lock out anybody that's not the owner of the table you're setting your level security on? Because you're doing an alter table.
You want to take
And
that?
you can only run that command if you own the employees table. So that would throw an error, so nobody can log into that database that doesn't own the employees table. Am I reading that right?
Yeah, that's correct. But the logic, I wanted to keep the logic as simple as possible. We can tweak the policy in such a way that only the owner of the table and the super user will be having the access to the whole table, and only the specific users will have this rule where he is going to able to access the rows which is created by him.
For everybody here, it's like that would effectively lock everybody out.
Yes.
Of the database.
Same question on that. So, is this commands that you're executing within the trigger, wouldn't we be able to execute outside of trigger? And whoever logs in has a, who would check the policy and see who's the current user and it's not allowed to do that, rather than me writing that in trigger?
So this we are trying to dynamically do it in the sense in the login trigger based on a user, specific user, based on the role, based on the specific client IP address, based on the.
If there are 100 login happening, you gonna execute alter table employee command 100 times.
Yeah, for a specific table, if there is a sensitive table and you want to ensure there is a role level security on that particular table, and you want to do it at the time of login, you can choose to do that as well.
One
has
The
to be
failure,
split.
in the sense of saying syntactical errors.
Can you be a bit louder?
The failures in the triggers, you mean to say like in the syntactical errors in the triggers, they don't need to top out all the units. It's not like the failure to log in into the data, like wrong password or something else. That's like
No, just to give an example, so in a trigger function code, you have an error. You compile the trigger and it's working. And the user is successfully authenticated, he gave the current username and password. But after the authentication, if there is any failure in the trigger function code, obviously the user will not be able to log in. So you need to check the trigger function code, whatever you are writing, it's syntactically correct and there are no mistakes. Thank you. Thank you all.